Simple harmonic motion problem number 5 on the web assign. We have a stiff spring attached to the ground. There's a horse. That's my horse. Okay, it's a chair. There's a kid sitting in this thing. All right, you know, wow, that's really something. Put a hat on him so you can tell it's a kid. And we're supposed to figure out what the frequency of oscillation is with some information given. Basically, the frequency of oscillation, you know, it oscillates up and down. Frequency. We're given the frequency of oscillation when we have the kid on it. Right? It says what it is when the kid's on it. Frequency is equal to 0.88 cycles per second or hertz with kid. We want F without kid. That's what we want. The frequency without the kid. Well, let's start with the big picture. Period is equal to 2 pi square root of m over k. Therefore, frequency, which is 1 over period, is 1 over 2 pi square root of k over m. So this is the formula we're going to use. Now let's see. We have two things we don't know, k and m. We know the mass of the kid. We don't know the mass of the horse. And so that's something we're going to have to figure out. We also have to figure out what k is. Well, we can figure out what k is because we are given the mass of kid, the mass, I'll say this, mass kid known. And then x is known as well. What can we do with that? If we know how much it compresses when the kid is on it, then we know that mg, the weight of the kid, I should say m sub k, g, is equal to k times x. We're given the mass of the kid. We know what g is, 9.8. We don't know what k is, but we know what x is. Therefore, we can solve for k. The spring constant in this case is the weight of the kid, m kid g, over x. So we're given this, and that's equal to some number. Well, that's equal to k. Yay, k, there it is. K exclamation mark. So now we know k. So we come back up here and say, okay, I know what k is, so the only thing we have to worry about is m. Well, since the entire system is oscillating at 0.88 hertz, you know, with kid and all, just go 0.88 is equal to 1 over 2 pi square root of k, which you now know, over m. Really what I should have done is forget about this. I like to write it as frequency is equal to. All right, basically what you got to do is you got to solve for this m. All right, so if we multiply by 2 pi, we have 2 pi f. I'm forgetting about the 0.88 right now, just doing the algebra. 2 pi f is equal to square root of k over m. This is like m total here. Okay, so square both sides. 4 pi squared f squared is equal to k over m total. Therefore, m total is equal to k over 4 pi squared f squared, where f is 0.88. Okay, so that should give you the total mass. And then what you're going to do is mass of the horse is equal to mass total minus mass of the kid. Yay! All right, so that'll give you the horse mass. And then from there, you just stick it in that frequency equation again. You got to solve for the frequency. Frequency equals 1 over 2 pi square root of k, which you now know. This is now known. Sorry, I'm writing this in the radical. K is known over m of the horse, which you have now discovered from this. Stick that in here, and that should equal your correct value. Yay! And you have a lot of satisfaction when the little green check mark comes up in WebAssign.